Hello guys, welcome to an Academy, a ThOD YouTube channel for GATE and ESC. This is your KP sir live on YouTube channel. Before going to start today's session, I would like to introduce myself, Krishna Prakash. Students love to call me EE sir. I was very much famous for environmental engineering. So students love to call me EE sir or KP sir. Have 16 years of teaching experience, trained more than 150 batches for GATE, ESC and also state government AE, A-double exams. And I am the ex-faculty of ACE Academy, now star educator in an academy and leading English teaching faculty of civil engineering group. So I will take care everything regarding your scheduling, subjects. I will take care about your preparation. And in an academy, I am going to teach the subjects environmental engineering, hydrology, irrigation, open channel flow, construction materials and management. I am famous for simplifying the subjects and I will provide you shortcut formulas which can be solved in the GATE exam in 1 minute or less than 1 minute time duration. And the vast and lengthy theoretical subjects, I will make it easy for you by providing tables, by providing flowcharts, some diagrammatic representation, so that huge theory easily understand for you. I am famous for monitoring, mentoring student preparation, best motivator. So if you want, I will provide you best strategy according to your strengths and weakness. So follow me in an academy and watch my free lectures. Check my profile KP Civil. Watch all free classes. If you want to take plus subscription, join an academy with my code KP Civil. Anything related to your academics, your career, your subject related doubts, preparation related doubts, anything, contact me, WhatsApp me. My mobile number given there, 898593312. And if you want to take full length course on an academy, use my code KP Civil or Engineering Guru. Okay, let's begin the session. Now, coming to the present topic, ThOD, theoretical oxygen demand. We have different types of oxygen demands in sewage. BOD, COD, ThOD, ultimate BOD, like that we'll discuss so many different types of oxygen demands in sewage. In that, one of the oxygen demand now, ThOD, theoretical oxygen demand. What is this ThOD? This is said to be amount of oxygen required to degrade, amount of oxygen required to degrade organic materials in sewage, organic compounds in sewage. This is what we are discussing, BOD and COD. Na? Then what is the difference between? Because oxygen required to degrade organic matter is BOD by biochemical degradation. Oxygen required to degrade organic matter is COD by chemical or biochemical degradation. Then what is the speciality of ThOD? This is the amount of oxygen required to degrade organic matter, which is estimated. The name itself given you the clue. Have you got the clue? Have you got the clue? Name itself provided the clue. Estimated theoretically, not by laboratory technique, not by practical method. You are not consuming even a single droplet of chemical. You are not using any bacteria to perform the activity. Even you are not taking sewage sample. Theoretically, on paper, you are calculating. You understand? Even you are not taking 1 liter or 1 droplet of sewage. You are just estimating on paper, theoretically, so that we are considering theoretical oxygen demand. Amount of oxygen required to degrade organic matter, which is estimated theoretically. How we are estimating? Using what you are using? Chemical equation of degradation. Using chemical equation of degradation. That means you are writing oxygen chemical reaction with that component. On paper you are writing oxygen chemical reaction with the chemical component, and how oxygen is breaking down and resulting other molecule. That chemical equation of degradation and molecular weights and also concentration of chemicals So using chemical equation of degradation, molecular weight of the chemicals, and how much amount concentration of that chemical present in the sewage. Using this theoretically on paper, what you are estimating is considered as ThOD, theoretical oxygen demand. You understand? Oxygen demands in sewage. Before going to know about it, first of all, oxygen demands in sewage. How many types? I think you know about it very well. Oxygen demands in sewage, we can classify into ThOD, oxygen required for biochemical degradation. BOD, oxygen for biochemical degradation, that is biodegradation. Who is performing it? Who is performing? Are you doing? No. Bacteria. Oxygen required for biodegradation. This biodegradation, who is performing? Tell me. Bacteria. Biodegradation. That is BOD. Second one. What is second one? COD. Chemical oxygen demand. Chemical oxygen demand. Oxygen required for both biodegradation and non-biodegradation. Finally, your target is 100% degradation of organic matter. 100% degradation of organic matter. It may be degraded by bacteria. It may be degraded by physical chemical forces, irrespective of it. For total oxygen to be degraded, clear? For total organic matter to be degraded, total amount of oxygen required, that is called chemical oxygen demand, COD. We can write down COD is a sum of, it is a sum of BOD plus oxygen for non-biodegradation. Oxygen for non-biodegradation, that is taken as COD. Now the same value of COD, which is estimated on paper theoretically using chemical equation using molecular weights, concentrations, everything. On paper, remember carefully, not practically. So COD, which is estimated on paper, theoretically, that is called theoretical oxygen demand using chemical equations. That is ThOD. Oxygen demand estimated theoretically. So if I say like this, understanding is very much difficult for you, confusing. I will explain with a simple and a small example to you, so that the total concept become crystal clear to you. Okay? Okay, we'll move on. For example, it was given water sample contain glucose. Water sample contain glucose of concentration 100 milligram per liter. Then in the exam they will give the question. Directly they won't ask you estimate ThOD. They will ask you estimate the amount of oxygen required. This is most repeated in GATE and ESC. Estimate the amount of oxygen required for degradation of 100 milligram per liter of glucose or some X milligram per liter of some other chemical. So estimate the amount of oxygen required. So nothing is provided on theoretically on paper you are doing. That the amount of oxygen required, what you are estimating, you call it as ThOD. Don't confuse the word ThOD given or not given. The word they will give. Estimate the amount of oxygen required. Nothing provided. Just concentration given and asked to estimate the amount of oxygen required. What is glucose? Glucose is 100. But chemical equation is provided. Or you can write down. If not provided, you can write down. Glucose. C6H12O6. Glucose molecular formula. C6H12O6 reacts with 6 molecules of oxygen. Gives rise to 6 H2O and 6 carbon dioxide. 1 molecule of glucose reacts with 6 molecules of oxygen, resulting 6 water molecules, 6 carbon dioxide molecules. Is it clear? 1 molecule of glucose reacts with 6 molecules of oxygen, resulting 6 water molecules and 6 carbon dioxide molecules. We don't want what it results, we don't want actually, because we need this amount of oxygen. Glucose is given. Glucose how much? 100 milligram per liter. For 100 milligram per liter of glucose, for 100 milligram per liter of glucose, how many oxygen concentration is required? How much oxygen concentration is required? So this is concentration. Now first we determine molecular weight of glucose. First we'll determine molecular weight of glucose. Glucose molecular weight, write down. Carbon atomic weight is 12. 6 carbon atoms are there. 6 carbon atoms are there. So each carbon atom atomic weight is 12. 6 into 12 plus hydrogen. Atomic weight is 1. 12 hydrogens are there. 12 into 1. Clear? Atomic weight of carbon 12. 6 are there. 6 into 12. Atomic weight of hydrogen 1. 12 are there. 12 into 1. Plus 6 oxygens are there. Atomic weight is 16. Atomic weight is 16. So total what is molecular weight of glucose? Molecular weight of glucose sum. What is molecular weight here? 180. So molecular weight of glucose is 180. We consider 180 parts. 180 parts containing glucose concentration 100 mg per liter. What is oxygen molecular weight? 6 oxygens, each with 32. Why I am taking 32? Why not 16? Oxygen molecule O2. It is not O. If it is just O, you take 16. Oxygen molecule O2. O2 we are considering 6 into 32. For 180 parts, concentration is 100 mg per liter. For 6 into 32 means 192. For 192 parts, what is 192 parts? Oxygen. What is required concentration? You understand it? Glucose of molecular weight 180 parts, 100 mg per liter. Oxygen of molecular weight 192 parts. How much concentration? Simple, no? Amount of oxygen is equal to, just do simple cross multiplication. You will get the answer. Just cross multiplication, 100 into 192 divided by 180. 100 into 192 divided by 180. Tell me the answer. Tell me the answer. Calculate it. Just cross multiplication. 100 into 192 divided by 180. How much you are getting? So after calculation, how much you are getting? 106.66 mg per liter. Mg per liter. This is oxygen concentration, which we call it as ThOD, theoretical oxygen demand, which we call it as ThOD, theoretical oxygen demand. Clear? So for this calculation, I will give you a simple sweet cut, shortcut formula. Okay? You may call it as sweet cut formula or shortcut formula, that is up to you. Direct determination of ThOD or direct determination of amount of oxygen required. Direct determination of ThOD or direct determination of amount of oxygen required. For any chemical, single shortcut formula I am giving. ThOD is equal to, take your given chemical name as X. For example, glucose is taken as X and its concentration. So given chemical concentration X in milligram per liter into N into 32 divided by molecular weight of X, mx. This is a simple direct sweet cut formula. Concentration of given chemical, this is X. Whatever your chemical given, no problem. X in milligram per liter, you take it. Concentration of given chemical. Given chemical, X in milligram per liter. mx, molecular weight of X. That given chemical molecular weight is estimated and taken as mx. What is N? Number of oxygen molecules required for degradation. Remember, oxygen molecules O2 we are taking, not O. Number of oxygen molecules required for degradation. We are not taking O. Again and again I am repeating. O2 is molecule, O is atom. Because why I am stressing? Because I have considered molecular weight as 32, not 16. Okay. N into 32. 32 is oxygen molecular weight, O2. Oxygen molecules molecular weight. 32 I have taken directly. It will not change na. Oxygen molecular weight will not change from chemical to chemical na. So 32 directly taken. ThOD is equal to X in milligram per liter into N into 32 by mx, molecular weight of X. That is the theoretical oxygen demand or amount of oxygen required. Okay. We'll solve one more problem related to it. Write down the question so that it is easy for you. The concentration of C2H5OH in water is found to be, the concentration of C2H5OH in water is found to be 350 milligram per liter. Estimate amount of oxygen required for its degradation. Estimate amount of oxygen required for its degradation. So first we'll consider C2H5OH, ethyl alcohol, reacts with 3 oxygen molecules, resulting 2 CO2 and 3 H2O. Ethyl alcohol C2H5OH reacts with 3 oxygen molecules resulting 2 CO2 and 3 H2O. Now C2H5OH, what is molecular weight? This is required, molecular weight is required. Carbon 2 are present, 2 into 12, plus hydrogen total 6 are present, plus 6, plus 1 oxygen 16. So what is molecular weight of C2H5OH? 12 into 2, 24, plus 6, 30, plus 16, 46. Molecular weight of C2H5OH, 46. Now we are applying our formula. ThOD is equal to. So you apply our formula ThOD. What you can write down? Given concentration. What is the value of given concentration? What is the value of given concentration? 350. 350 into our formula into N. What is N? 3. N is 3 na? 3 oxygen molecules required. N is 3. 3 into 32 divided by 46. Now you will get the answer for ThOD, theoretical oxygen demand. How much you are getting? Tell me. 730.43 milligram per liter. So to degrade 350 mg per liter of ethyl alcohol, you need 730.43 mg per liter of oxygen according to theoretical calculation. Okay? Practically it may be same, it may be more than, it may be less than. As per theoretical calculation, 730.43 mg per liter required. Clear? 730.43 milligrams of oxygen is required to degrade ethyl alcohol. Write down next question. A sample of water found to be carrying 300 milligram per liter of glucose. And the water treatment plant receives 20 mld of water for its degradation. 20 mld of water for its degradation. Estimate amount of oxygen required to treat water in kg per day. To treat water in kg per day. The question looks simple because already we have solved for glucose. Na? Directly we'll take it now. Glucose 300 milligram per liter. C6H12O6 plus 6O2 gives 6CO2 and 6H2O. Glucose molecular weight. Already we have estimated. In the first question we have estimated the molecular weight 180. So we'll solve it. ThOD is equal to 300 into how many molecules of oxygen? 6 molecules of oxygen. 6 molecules of oxygen. 6 into oxygen molecular weight will take 32 divided by what is glucose molecular weight? Glucose molecular weight is 180. Glucose molecular weight is 180. So what is the value of ThOD you are getting? 300 is concentration of glucose. 6 oxygens you are using. Oxygen molecular weight 32 divided by glucose molecular weight 180. So what you are getting? 320 mg per liter is amount of ThOD. Is the question is completed? Is your question is completed? No. Because it was given to estimate in kg per day. not in milligram per liter. You have estimated in mg per liter. You have to determine in kg per day. Water treatment plant is going to treat. Water treatment plant is going to treat 20 mld of water. 20 into 10 power 6 liter per day of water. Each 1 liter water needs 320 milligrams of oxygen. Now what is the total oxygen requirement? Just multiplication only, no? Total oxygen requirement for 1 day expressed in kg per day. Kg per day. Every day you are going to treat 20 mld. For 1 day, water treatment plant treats 20 mld. 20 into 10 power 6. Each 1 liter carries 320 milligrams. To convert milligram to kg, I am multiplying with 10 power minus 6. Okay. Because we need answer in kg. 1 kg is equal to 10 power 6 milligram. So 1 milligram is equal to 10 power minus 6 kg. To convert milligram to kg, I am multiplying with 10 power minus 6. So 10 power 6, 10 power minus 6 getting cancelled. This is the answer you are getting. 6400 kg per day. 6400 kg per day is the amount of oxygen required for the entire water to undergo treatment. Clear? So this is regarding ThOD and its numerical calculations. Hope you enjoyed. I hope you enjoyed the session. Before going to close the session, a small announcement. Join plus subscription full-length course of GATE and ESC and Unacademy. Trust the best for your GATE and ESC preparation. The faculty in Unacademy are top-most faculty. They will give you the best subject, in-depth subject knowledge, and also they have vast experience in teaching, especially GATE and ESC, exam-specific teaching. And the platform of Unacademy is the largest online edutech company in India. It provides live interactive classes. Whatever your doubt, if you put in the comment box, easily, immediately your doubt is clarified. Have you downloaded Unacademy app? If not, today download the Unacademy app. In the search button, click KP Civil, follow me, watch my previous sessions and upcoming sessions also. Whatever your doubts easily clarified immediately within 1 minute of your message. You understand? Live interactive sessions. If you take a plus subscription in Unacademy, I will provide from my side free study material. I will provide from my side one free online test series. Unacademy is giving you one test series. Myself will provide you another test series. 2 online test series you will get. And also, if you miss the session, don't worry. Your already completed class is recorded. You can watch twice, thrice, how many number of times you require. That many times. Just for example, I will tell you. I am teaching environmental engineering 140 hours. You can understand the depth of subjects I am providing. The depth of environmental engineering 140 hours, you can write any kind of examination from that 140 hours only. It may be GATE, IAS, AE, AW, whatever the exam you can write. That 140 hours sessions is more than enough. A single solution for any kind of examination. So, join Unacademy, excel your GATE and ESC preparation, use my code KP Civil or Engineering Guru, take plus subscription, get all the benefits. If you have any doubt, any query related to subject point of view, career point of view, preparation strategy point of view, any doubts related to Plus subscription, whom to follow, whom not to follow, what to study, what not to study, don't worry, your KPs are with you till you crack GATE and SC. WhatsApp me, my mobile number is given there, 898593312. We together grow up. I am with you, my team of faculty with you till you crack GATE and SC. Then why to wait? Join Plus course in an academy using KP Civil Code. Let's crack it.